Hello, and thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBV Elektronik.
Welcome to the Passion for Technology podcast. Today's episode is dedicated to edge computing. It's a technology that's often underestimated by the public because it works behind the scenes. Edge computing refers to data being processed at the extreme periphery of the internet, at the edge. In other words, directly where it's being aggregated and produced. What advantages does this offer? What role does semiconductor technology play? And where are future developments heading? We'd like to address these questions and more issues related to edge computing with today's guest, Ulrich Schmidt, Segment Director High-End Processing at EBV Elektronik. Welcome, Ulrich.
Hello, Mustafa.
I mentioned how edge computing happens behind the scenes. Where are we most likely to encounter edge computing in our daily lives?
Smartphones are those devices where you see edge computing applied in everyone's life. There's so much data these devices produce and process that's just amazing. And of course, wherever you have lots of data accumulated in real time, this is where all these edge devices and edge computing is used in the future.
Edge computing is no longer a niche technology. How widespread is it?
Probably it never been really a niche technology. There has been just an evolution of this technology over the years. By now, all the semiconductor became so powerful over time that this technology is adopted in more and more areas, and we'll see that throughout this podcast.
Uli, how would you then define edge computing?
Edge computing is the place at the edge where all the data, and typically massively data, is collected and processed before it actually gets transmissioned into the cloud.
So now we're talking about edge computing. And when researching edge computing, there's another term one stumbles upon, and that's edge processing. Is there a difference, or are the terms synonymous?
To me, edge processing is more a dedicated area of this whole edge computing task, where specific devices, for example, an image sensor processor, just takes care of the processing of the image sensor data that is received. While, again, edge computing is more a generous combination of different sensor data, and the aggregation combine all this information.
How is it all related to cloud computing?
Edge processing, edge computing is the place where the data is really collected. And due to latency issues, due to data bandwidth issues, there is no way of feeding all this data into the cloud. So there must be some processing upfront before it's sent to the cloud, where everyone can access data from everywhere, from different sensors, from different devices.
What advantages does edge computing offer?
As I stated previously, it is the real-time aspect of the data. Just to give an example with autonomous driving, where you can't wait for a decision to be made in the cloud. There's simply too much time that goes by to take a certain action. So edge processing offers the benefit of processing data in real time and lowers the data bandwidth just for the essential data that needs to be sent over into the cloud.
Can you give us a couple of typical applications of where edge computing is being used today?
We've given the example of the smartphone in the beginning, but there's the smartwatch collecting your health data. It's coffee machines that are controlled by voice commands. It's cobots in a factory that moves goods autonomously, or the thermostat at home to control your room temperature.
Uli, what type of hardware is needed in order to equip a device with the relevant capabilities?
This is a wide range of semiconductor that is used in devices. It's typically low power devices at the very edge of a sensor node, but there's lots of in between, like the gateway that requires more processing power, or even high-end processing, like the example we already talked about, ADAS, for example, which requires lots of processing from different sensors and lots of data that is collected.
That sounds a little complicated. Is this something that only semiconductor experts can use in order to equip their devices with edge capabilities? Or are there, modular solutions maybe that one could utilize?
Well, you mentioned modular solutions to start with. It's various RF modules for different standards, whether it's Wi-Fi, whether it's Bluetooth, that will be combined with other semiconductor equipment. And by now, semiconductor typically plays the second role in the decision, while software is more dominating the decision from those who build such equipments. There is both on the software side and on the hardware side modular approaches that help, for example, to connect your device to the cloud where all the stacks and building blocks are available from our vendors.
Can EBV provide assistance with upgrading a device with edge computing capabilities?
Thanks for this question. This is actually one of the great examples where EBV could help, as we see ourselves as an independent consultant and also with a focus on solutions. That means that we try to give the customer the best advice, which semiconductor works probably best for their particular problem they are going to solve, as well as finding the software solutions and engaging with partners to give all the information a customer needs to build such a edge computing device.
Focusing on the semiconductor perspective, what type of chips are being used at the edge, and has edge computing inspired any new developments in the industry?
To me, while we see an evolution in the products from our semiconductors, more and more building blocks will be integrated in these devices. So in the past, you have the CPUs with the peripherals surrounding it. By now, you will find more and more hardware acceleration dedicated to solve a certain problem, like the mentioned image sensor processor, like the neural network accelerators to accelerate artificial intelligence issues. So there's, to me, a high integration of all these components you find on these chips.
Willie, where is edge computing going in terms of hardware?
We see that still Moore's law is not at its end yet. There is still a higher integration. We will see even more powerful, even more dedicated devices that help the customer to solve a particular problem. So communication will definitely be a big part of all the future devices that will come, as well as dedicated acceleration that might come in the future.
How will this translate to future applications? What type of applications do you see next?
The mentioned autonomous driving is probably one of the driving factors for all these developments, whether it's in the algorithms for AI, for all the sensor fusion in combining all sorts of data in a single device, so that there are numerous things that we will see in the future, in particular that all the devices at the edge become more and more powerful, and basically all the processing still moves towards the edge.
How is edge computing changing the IT landscape, and what role will it play in the future?
It's been part of this podcast already that data and the sheer amount of data is one of the essential ingredients for edge computing. So we need to deal with interfaces that support higher speeds. It's the advent of 5G that is used in many areas, providing high bandwidth, low latency in the communication. So there's a lot of data that needs to be handled, and not to forget about security to make all your connections secure. That's probably one of the things that will play an even more important role in the future.
Uli, thank you for the insights that you've shared with us today. Now, I'd love to know when and how you developed your individual passion for technology.
Well, I started probably in the age of 16, designing or making first designs with TTL logic, with the 74 series of logic. then sneaked into the controller with the 6502, making my first programming experiences. And over time, I always tried to keep pace with this really fascinating technology where there is more and more processing power available in very small chips, whereas you had to install huge racks of compute power somewhere. So this is just fascinating on what is going to happen.
Dear listeners, if you'd like to get in touch with Ulrich, feel free to reach out to him and his team via the email address high-and-processing@ebv.com. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Uli, thank you for joining us today.
Thank you, Mustafa.